Illustrative math, geometry, unit 1, lesson 21 is called 180. So our goal today, we really only have one goal, is I can prove that the sum of angles in a triangle equals 180 degrees. All right, so a little review here. A linear pair is two adjacent angles that form a straight line, which means their sum is 180 degrees. So angle 1 and angle 2 right here are a linear pair. So we know for sure that these two angles together add up to 180. Okay, so angle 1 plus really the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Okay, and a linear triple is three adjacent angles that form a straight line, which means that their sum is 180 degrees. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees, okay? All right, so we're going to do a quick proof here. So if BC is parallel to DE, okay, we can say that the measure of angle CBA right here is equal to the measure of angle DAB right here because they're alternate interior angles. Okay, so ABC and BAD are alternate interior angles. So you can see right here, if I were to trace this angle, you can see with rigid motion, if I rotate it and translate it down there, you can see that they're congruent. So I can fill the 33 in right there like I have. Okay, so there we go. And then likewise here, these are alternate interior angles as well, because this would be my transversal over here. 64, right here, angle BCA and CAE are congruent by alternate interior angles. So there we go, BCA and CAE are congruent. So there you go, they're both 64. And again, if I were to trace this, there it is. Actually, let me redo that. That looks terrible. There you go. It's a little better. I'm going to rotate and translate. You can see that they are indeed congruent. Okay. So we know that these are a linear triple. So basically what we have here is these three angles equal 180. So 33 plus x plus 64 equals 180, right? Because they all are linear triple. But if you look up here in the triangle, it's the same thing, okay? So we have 33 plus x plus 64 in the triangle. So, you know, with the linear triple here, can't spell. There we go, linear triple. And then with the triangle, there's my triangle, you can see that they're the same equation. So we could probably conclude that the sum of the angles in a triangle is also 180, okay? So the measure of angle BAD plus the measure of x plus the measure of CAE equals 180 because the three angles form a straight line. So the value of x must be 83, okay? So you can see it right there. If I subtract these two from 180, I get the 83 right there. So it's with the line and it's also in the triangle. All right, here's another one. So this 57 is right there by alternate interior angles. So, you know, I would say the measure of angle JIH is equal to the measure of angle KHI, and that's by alternate interior angles. use the same color there since that's in blue. And then over here, same thing here, the measure of angle IJH equals the measure of angle LHJ. And again, that's the same thing, alternate interior angles. Okay, so this angle up here is the same as right there, so that's 45. Okay, therefore, (57) plus x plus 45 equals 180 with the straight line because the linear triple and in the triangle. Therefore, x is equal to, let's see here, 78. Okay, so I'd have to subtract both those from 180. Okay, so there you go. You can see in the triangle or on the straight line, they're the same. All right, so another way is with rigid motions. So translate triangle ABC along directed line segment from B to C. Okay, so let's do this. Let's put our directed line segment up here first. So the directed line segment from B to C. And let's trace this triangle here. All right, so translate triangle ABC along the directed line segment from B to C. Make triangle A prime, B prime, C prime. So right there. So I will label these. This is going to be B prime right there. This is A prime, and this is C prime. Okay. All right, number 2. Translate triangle A prime, B prime, C prime along directed line segment from A prime to C. So A prime to C. So A prime to C would be right there. Let's get rid of this. All right, so we're going to do that. We're going to right there. Okay. So this will be triangle. This is going to be a double prime. I'm going to get rid of these here. So this will be a double prime. And then this will be C double prime. And this will be B double prime. Label the measures of the angles in triangle A double prime, B double prime, C double prime. Okay, so this was B, lowercase b degrees. This was A degrees, and this was C degrees. Okay. Label the measures of the angles that meet at point C. Okay. So explain your reasoning. Okay. So I got A here. I got C right here. This is going to be B. Why is that B? Well, if I did a rotation here, I would did a rotation and a reflection, I could get B right there. Because if you look over here, I could take this triangle and I could right here at the midpoint rotate it around, and the B would fit right in there. Okay, so I got A, B, C. So they all form a straight line right here. Okay, so A plus B plus C equal 180, and they're a linear triple. Okay, so there you go. There's your your rigid motion proof. So look back at the two proofs of the triangle sum theorem. Are there any parts of the argument that depend on the particular measurements of your triangle? Or would the same arguments have worked with other kinds of triangles? I think they would generally always work. Your pictures would be a little different from here or there, but the first one used specific numbers. If you had, more general statements without like specific angle measures, it might be a little bit more broad. So how are the two proofs of the triangle angle sum theorem different? How are they the same? They both use a linear triple. The rigid motions, one uses alternate interior angles. The other uses rigid motion. They both accurately show that the sum of all three angles in a triangle equals 180 degrees. Okay, so they're both accurate in that regard. All right, so here's the triangle sum theorem. The three angle measures of any triangle always sum to 180 degrees. All right, so here's your picture. Obviously, this side here is parallel to that line. You might need to make sure that you understand that. And you can move the C right here because they're alternate interior. Move the B right here because those are alternate interior. And then you can say, oh, well, A plus B plus C equals 180 because they're a linear triple. All right, Elena wants to prove that the measures of the three angles in the triangle always sum to 180 degrees. She starts by using rigid motions to rotate ABC 180 degrees around two midpoints. Explain how Elena labeled her diagram and finish her proof. Okay, so this is my original. So when I rotate this around here, around this midpoint, this B swings right there to 180, and then this A is going to come right here. So really this would be A, this would be C. We don't need these though. Right here, when I swing this C swings up here 180, the A comes down here, and the B comes over here from rotating this triangle over here around this point. But what we really need is this right here, because these are linear triple, and linear triples we know add up to 180. So A plus B plus C equals 180, which when you look at the three angles A, B, and C, you can see that they're the same angles in the triangle and at the line. Okay, so right here, when you look at the triangle, they're the same three angles. So if they add up to 180 here on the line, they're going to add up to 180 here in the triangle. Okay, so there you go. So our goal today, I can prove the angles in a triangle sum to 180. So you're going to have to use rigid motions, or you're going to have to just move angles with the alternate interior angle theorem. Okay, so that's it for this lesson, and hope to see you next time. Thanks for watching, and we'll see you later.